Hello everyone, Meteorologist Matt Holiner here. Going to spend some time talking about humidity because it makes such a big difference in how it feels outside. We want low humidity, we don't want high humidity. And when we have low humidity, it can feel a lot better than when we have high humidity. Now, what we like to show to describe humidity are the dew point temperatures. Now, remember, dew point temperatures are different from air temperatures. Sometimes the dew point temperature and air temperature can be very similar. Other times they can be very different. So we do like to show you a dew point temperature map, but oftentimes people do get confused because it looks so much like a temperature map. So we like to break out the muggy meter to help explain what those dew point temperatures mean. And in general, the lower the dew point temperature, the less humid it is. The higher the dew point temperature, the more humid it is. And here in the valley, we spend most of our time with dew points in the 40s to the 70s. And I tell you what, in the summer months, we spend a lot of time with dew points in the 60s and 70s. It's often quite humid here. When dew points are in the 40s, that's dry air. And even when dew points are in the 50s, it feels very nice outside. Once dew point temperatures get into the 60s, though, it certainly feels muggy. And when we have dew points in the 70s, that's very humid. Occasionally, dew points will be in the 80s, and that's really humid. Just feels pretty awful outside. And then during the winter months, sometimes dew points will drop into the 30s and 20s, and that's very dry air. So dry, you might be breaking out the hand cream. So we like to explain humidity using dew point temperature, but oftentimes we do get questions like, why don't you show the relative humidity? Or some people have home weather stations that show the relative humidity, and sometimes the relative humidity can be very high, but we'll tell you that the humidity is not high. That's because of the term relative. Relative humidity means humidity relative to something, and in this case, it's relative to the temperature. And the warmer it is, the more moisture the atmosphere can hold. And this explains why relative humidity sometimes isn't the best tool to describe the humidity, because when it's chilly outside, when the temperature is 55, a dew point of 37, which is very dry air, means the relative humidity is 50%. When it's a little bit warmer, the atmosphere can hold more water, so the dew point can be 55, and the relative humidity, again, the dew point temperature relative to the temperature is still 50%. Meanwhile, when it's 95 degrees outside, the dew point can be 74, which is very humid, and the relative humidity is still just going to be 50%. So that's a huge difference. The relative humidity can be 50% when it's very humid outside, and the relative humidity can be 50% when it's very dry outside. So that's why we try to avoid using relative humidity, because it's not the best describer of how humid it really is. So you might be thinking, well, then relative humidity is worthless. Not quite. There is an exception. It's useful for identifying when clouds are going to form, and a great example is when there's going to be fog. If the surface temperature is 58 degrees and the surface dew point temperature is 58 degrees, like in this example in Harlingen, that means the relative humidity is 100%. And when the relative humidity is 100%, that means a cloud can form. And in this case, a cloud can form on the ground, which is fog. And this also becomes helpful when forecasting the weather as well, because sometimes, a lot of times, the relative humidity won't be 100% at the surface, but it will be aloft, because keep in mind, typically, you see temperatures cool with height in the atmosphere. So it'll be 85 degrees at the surface, but you go up several thousand feet, and it's actually 70 degrees when you go up several thousand feet. And so if the humidity is the same at all levels of the atmosphere, there won't be any clouds at the surface, there won't be any fog, but you go up a couple thousand feet, and there the dew point temperature is 70, the air temperature at that height is 70, so the relative humidity is 100%, and so a cloud can form, and that becomes very helpful. If it's really dry air at all levels of the atmosphere, it might be a bright sunny day. But especially in the winter months when it's a little bit chillier, the air temperatures are chillier, it might not take as much humidity for clouds to form. That's why it tends to be cloudier during our winter months than the summer months. So it's so warm, it takes a lot of humidity then to get that relative humidity to 100% and for clouds to form. So hopefully you have a little bit better understanding now of humidity and the difference between dew point temperatures and relative humidity. Thanks for watching.